Hey, everybody. Welcome to Cassandra Lunch 28. Today, we're going to be talking about Cassandra backup restore scenarios. Please reach out to us if you're interested in presenting a topic. Always looking for people to help co-organize. We're part of a larger community called Data Community DC, which is made up of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 different meetups now. We cover Cassandra-centered platforms in which Cassandra protocol is the main storage layer. What I mean by Cassandra protocol, well, ScyllaDB, Gigabyte, managed key spaces, Cosmos DB, these are Cassandra compliant in terms of the protocol to store and retrieve data. Some of them are even architected in the same way as Cassandra. We aren't any new people today, but we had a request from JB on snapshotting, and so we're going to talk about backup restore. If you have a question, just ask it or put it in the chat. DataStax is a partner and a sponsor. So is GW and some local sponsors. And here are some institutional sponsors. We have a few announcements. You can always find these videos on Cassandra Lunch on YouTube. Our website continues to iterate with new features. Take a look. We're constantly adding new knowledge. And we actually had a Cassandra event, Cassandra and Spark event yesterday. We're having one tomorrow about how to use notebooks. And there's another one next week or the week after. Sorry, we've got a lot of stuff going on with DataStax as a weekly workshop. All right, so let's set the stage here. So JB, you had a question, right, about snapshotting. So why don't you ask the question and I can frame the answer based on that.
Yeah. What I understand is when we take the snapshot.
Hey JB, you're breaking up, man. Sorry. Or is it me that I'm breaking up?
Now the question is when I try.
Hey guys.
You're able to hear me?
Now I can hear you.
1 minute.
You're breaking up slightly.
Who is breaking up, me or JB?
1 minute.
JB.
Yeah. Maybe me.
All right, then we're gonna what I'm gonna do, JB.
You're able to hear me?
Yeah, we're able to hear you now. Go ahead.
Okay. When the way we were saying a snapshot, taking a snapshot is we are saying node tool and we are saying a snapshot on each node, correct?
Yep.
And then when I say restore means I'll be copying those files. I had taken the snapshot. Okay.
Yep.
Then I'm playing with my data, some tables. I'm ingesting some data or deleting, purging some data. All those stuffs I'm doing it. Now, now something happened. I have to restore it now.
Yeah.
Okay. If I am restoring only key space, okay, assume only one key space is impacted, but metadata related to that key space might have changed, right?
What type of metadata?
Metadata in the sense, what I'm saying in system key space, where when I'm doing the restoration, I'll come back. Okay, what I just want. When I'm doing the restoration, my background process like what is that gossiping and other stuffs, right? They will have a different statuses. When I'm doing the restore, how they will play?
Okay,
that's what my question is.
All right, let me start from the top. We'll come back to this.
Probably I'm not a.
Yeah, no, that's fine.
Yeah.
Let me start from the top. Okay, this is how Cassandra stores. We'll talk about how Cassandra stores data, right? And then we'll talk about what the snapshot. So we'll say Cassandra how does Cassandra store data? That's the first question, right? And then how does Cassandra backup work? And then how does Cassandra restore work? Okay, and this is there's a kind of two approaches. Same topology. Okay, all right, cool. So how does Cassandra store data? Well, on each node, okay, let's say there's a data center, right? And this is another data center with one node. Let me expand this here, for example. And on each of these nodes, right? If I were to zoom in, what's happening is here. There we go. And so this is node 1, right? You have a key space, right? We'll call this one key space is system. Okay, anything to do with system, we'll say it's over here. And then you have maybe another key space, which is your application key space, right? So on each node, right? On each node, it's going to store it in a directory. It's going to store, and I'll show it in the workflow in a second. It's going to store system schema information, as well as some system local information. And then for each key space, it's storing the data that belongs on that node for that particular key space, right? And if I have another node, it looks very similar. But the difference is that this data is slightly different because it stores different replicas, right? So now let's zoom in again. Let's look at this key space. So we'll call it application key space, right? And I'm gonna actually call it. Okay. And in our application key space, we'll put a couple of tables in there, right? So I don't want to black. I can't really see what's happening there if it's black. So we'll have, let's say, table 1. We'll call it users. We'll have another one for, let's say, preferences for the users. It's a common use case, actually. User preferences. Okay. So we have here one instance of the key space, and then in here, it's the data for just that table. And in here, it's just the data for just that table for this one machine. So the same thing, right? If you go to node 2, it'll have the same type of thing, right? That makes sense, right? Each node has a key space. In that key space, there's a table that has a directory. Another node, there's a key space, same key space. The same table directory will exist in that particular key space, in that folder on that machine, okay? What does that look like on the directory? It looks something like this. Generally, Cassandra will have varlib Cassandra data. That's where your data sits, okay? In here, there'll be your system key space directories. In here, you'll have, let's say, your application, right? And then you'll have something that looks like this. This is a GUID. It's like a big GUID, okay? And same thing with your preferences. And the reason it puts a GUID here is that when you make a schema on a cluster, okay, in the system, right, there is a list of key spaces. There's actually a list of also column families. In here, it stores the name of the table and a GUID associated with that table. Because what we don't want is when somebody restores data, okay, to accidentally restore data for one schema into the directory of another. Okay, now the metadata for this table is stored in these key spaces. Are you with me? I need some verbal.
Yep.
Okay.
With you.
All right, cool. So now let's talk about how does backup work. So the way that backup works is, we'll take a copy of it. We'll bring it down here. Okay. When you say node tool snapshot, right? What it will do is it will make a directory called snapshots. And in here, if you give it like a name, you can give like a tag to the snapshot, it will take and it will copy whatever is in here. It does what's called a hard link. So if these things changed, it still exists here. That's a Unix thing with inodes. I'm not going to get into it. But everything that's in here, you can assume is going to be in here. And if you snapshot it again, and if you don't give it a name, I think it just comes up with like a date-based name or something like that. It'll have everything here. But this snapshot does not include the metadata, the schema information for this table. Unless you're using Op Center backup, or I think Medusa, you have to take a schema dump. You have to have your schema for that table somewhere else. Now, if you delete this folder, let's do a restoration here. Okay. Same topology. Let's one kind of restoration. So if it's the same topology, what we do is we copy snapshot/snapshot name 2 star into this folder. And because we didn't change any schema here, right, it will work perfectly fine.
Rahul, this is the place I have a question now.
I know, that's why I'm saying I have to give the background so you understand.
Okay, sorry.
Yeah.
Huh?
Yeah, go ahead.
No, my question was, after taking a snapshot, data is changed. Schema is not changed.
Schema's not changed.
Data is changed.
Yep. So
Now,
if the only thing that's changed is data, all you need to do is copy it back into that directory.
In that case, my what to say is gossiping. See, for example, as a part of the gossiping, it checks the timestamps, right?
Mm-hmm. Yeah.
Now, my timestamp is old. One place is old, one place is new. Which one it actually I want with the old one?
So gossip, by the way, is only exchanging the state of the schema and the state of the server. Okay. Gossip, that's all that gossip moves around.
Somewhere when we are doing that compaction, it
Mhm.
looks for, okay, this is my late, it looks for the commit log, and it looks it looks for the SS tables, order the different timestamps, and it takes the latest timestamp, right?
Only on read. What you're talking about is when you read this data,
Yeah.
we'll take the latest one. Okay. Now, one thing that I think we didn't say is you have to do this operation on every machine.
Yeah.
Okay. So on every computer, go back to Mural for a second. On every computer, you're restoring the backup, the snapshot directly back into this, right? So if this is if this is the old data, and sorry, this is the new data, I will bring it back to the old data, okay? I'm gonna do it on every machine. I'm gonna restore it back, okay?
Yeah.
And then you don't do that while the server is running, right? You bring down the node, you copy the data, you bring back the server,
Okay.
right? You have to do, this is an offline operation.
Okay.
Taking a snapshot you can do online, but restoration you would never do that online.
Okay.
Okay.
And as a part of the, when we are doing the, okay, moment we are saying offline, that mem table is gone, right?
Yeah, mem tables are gone.
Okay. uh, then fine, understood.
Got
That
it?
means now my all the status are, I don't have a latest timestamp record, or whatever the name we can say, right?
Yep. Mm-hmm.
It will be only the old timestamp, and
Yeah.
thereby there is no chance of going back, in the sense data inconsistency.
Right. In fact, I mean, if you're worried, right, you would go and you'd clean out all the commit logs. Right.
Okay.
You could do that. But the way that you would bring down is, first, when you bring down the server, right, you would say node tool flush. And that would flush all the mem tables to the disk. And then when you replace it, it's not going to be an issue.
Node tool flush, I'll be doing it. Just I missed the one point in the.
Yeah, so this is a different question, right? How do you properly bring down a server? How to properly bring down a Cassandra node?
Okay.
Gotta do no tool flush, no tool drain, okay? And then you say whatever, stop, right? There's different ways to stop Cassandra.
Okay.
You don't do no tool stop. There's no, it's just basically you kill the Java daemon, or you run Cassandra service stop or something like that. But when you do flush, this is flushing mem tables into SS tables, right? That's what it does. And when it does that, it removes the commit log. Because what are the commit logs? The commit logs are what is going into mem tables simultaneously. The reason it writes to a commit log is that when a server accidentally goes down, it is able to rebuild the data that was in the mem tables. But if you flush the mem tables, it doesn't need the commit logs anymore.
Yeah.
What does no tool drain do? No tool drain basically stops taking writes.
Okay.
Stops taking traffic, essentially, right? Okay, so that's how you would do that. So you first snapshot, okay? Then one by one, basically, I mean, you can basically do this process where you snapshot on all of them. You have the snapshots. If you didn't change the schema, one by one, you could be restoring data without ever bringing down the server. Because if you just have to restore one table, why would you bring down the whole cluster, right? But you can restore one table at a time, one node at a time, like this. Okay. Here's
Okay. Here, if I have to just bring a restore one table, okay.
Mhm.
Again, in this particular case, we are not bringing the node.
No, you have to bring the node down. You cannot do this process. You cannot copy
Okay.
data into a running server. You have to bring the machine down, even for one table, but
Okay.
you don't bring down the whole cluster. That's what I'm trying to say. Just,
Okay.
right? You bring down one
Yeah.
node, you copy the data, you bring it up, and then you do the next one.
Okay.
Okay?
Okay. Okay. Yeah.
Now that's one way to do it. Okay? Same topology, copy, snapshot method. This does not work if you're restoring to a different topology that people will try to do. Right? So if you have here 2 nodes, this process works fine. Okay? But if all of a sudden you go from having 2 nodes to 3 nodes, okay? And you only have snapshots from 2 machines, right? What are you going to put over here?
Oh, yeah.
And by the way, the tokens are going to be all different.
Yeah.
That's why this doesn't work. But there's a different way to restore data back. In this case, we don't copy the files over. We use a different process. 1, 2, 1, 2, 3. Okay, so here's the nodes. And here are your files. Okay, and so what we do here is we use a process called SS table loader. I'll zoom in a second. Okay, and SS table loader you can run online. In fact, SS table loader you can even run in your scenario which you have the same topology. But what SS table loader is doing is it's taking from wherever your files are, right? It's reading it, but then it's writing that data back. And the way it writes it back is it basically, this is the wrong one. It's as if it's writing the data back to a, from a client, okay? And when it writes it back, wherever it writes it to figures out if that data belongs there. If it doesn't, it sends it to the right place. So the partitioner automatically spreads the data. Okay, and what people will commonly do is they will have an SS table loading operation coming from one machine. Oops. Right, they'll have an SS table loader operation happening from one machine, and then they'll have another SS table loader operation happening from another machine.
Okay.
And what is it doing? SS table loader is writing data natively to Cassandra as if you were writing it from another place, like via client. That's what SS table loader is doing.
Okay.
Okay. But SS table loader takes time. It's not fast because it has to rewrite the data. Whereas when you copy the data, it's like super fast, right?
Yeah.
Because all the data is already in the right structure and the right topology. Okay. And by the way, it doesn't matter if you have 15 SS table loader operations happening or 5, because they're all hitting the cluster and the cluster is just deciding where to send the data.
Yeah. It's what I understand is it's indirectly you are creating DMLs probably.
Yeah, that's what it's doing. It's just, it's taking the SS table and as if like when you, for example, if you lose a node, right? If you bring up another node, right? SS tables are streamed from one node to the other. In this case, it's taking each partition and it's sending it natively. It's not doing a CQL. It's more lower level than that, but it's kind of like that. Yeah.
Okay. In one more thing, in the previous same topology. Okay.
Mm-hmm.
Now I have copied the, I have brought down the one node. I copied my, I restored the files from the backup,
Yeah.
and now the fact is in the rest of the nodes in the cluster.
Yeah.
Okay, there is a discrepancy between the node what I just copied the data. I'm bringing it.
Okay. So let's say for you're doing it on one node, right?
I have finished with one node. Okay,
Yeah.
say we have three nodes. Okay,
Yeah.
I brought down the node. I copied I did the restoration of my files on that particular node.
Okay.
Now I have to move for the next node.
Yeah.
Okay,
Yeah.
before moving to the next node, I'll be bringing it up this particular node or no?
Yeah. You bring it up.
I'm bringing up. Now what happening is the data in the node 1
Yeah.
and for that particular table,
Mhm.
and node 2 and node 3 there is a discrepancy.
There's a discrepancy, and this latest data will override it. That's what you're saying, right? This has newer data and this has older data.
How the reads will ensure that okay, there is a discrepancy, I should not fail, or we should not jumble up the things. That's
But-
my question is.
Right. So this is what I'm saying is that when you are operating on a live cluster, okay,
Yes.
when you're operating on a live cluster, your operations, right, have to be, you have to think about the operations. How important is this data? Okay. If it's important that it gets served up at some point, then you cannot clean house on it. You have to have an older version of the data while you do a rolling restart and you copy these files over. Okay.
Okay.
The other approach is you just literally you truncate the table, and then there's no data, and then you copy
Okay.
over old data. That's what I would do for you to not have discrepancies, or basically have old zombie data take over.
Yeah, because otherwise it will be like a kiosk, right?
Yeah, you'll have old data, you'll have new data, and it because it reconciles it, and it could send a read repair back to the backup data. Yeah, absolutely. So if you want to have completely original data, that's what you would do.
Yeah, I want original data.
Yeah.
And I don't want this what you mentioned, read repair, all those stuffs to be happening in between.
Right, but that's not gossip. That's what I wanted to be clear with you.
Yeah.
Right? That's a
No,
read repair.
yeah.
Yeah.
Sorry, when I was saying gossip, my
Yeah.
objective was to say, okay, there is a, I'm not able to get that particular wordings.
Yeah.
When we do the compression, it looks for mem tables, all those records. It looks for the when this particular compaction. Yeah.
Compaction. Yeah.
Yeah.
Exactly.
When this particular record is written or this particular column is written, and
Yeah.
it compares with the all the SS tables and mem tables, then it reconciles, right?
Yeah. Yeah.
In that process, it should not mess up the things. That was my question was.
Right. Well, not compaction doesn't do that. Repair does what you're talking about. But yeah, there is some operations that would be messed up with compaction. So yeah, you're absolutely right. It has a potential impact when you do that. But if you just want to have the raw snapshot back, you got to basically truncate and then go from there.
Okay.
Okay.
That particular data will be offline for some time. Yeah, that's fine.
Yeah, that particular data will be offline for some time. Yep. I mean, and then again,
The reason I'm saying if that data is huge, okay,
yeah.
even though may not be having much importance.
Yeah.
Yeah.
So now I'll talk about how to have a high availability right in a second. So,
okay.
So different topology, what are we doing? Different topology, you just SS table loader. Right? So The issue here is that it's going to be slow, right? Okay, now, how do you keep it running, okay, while doing a restoration? That's the thing. In this case, you kind of have to think about, so the question is, how do we keep a cluster available with data while doing a restoration? Right, that's the question. Is that the question, JB?
Correct.
Okay. So good. So scenario is, let's say there's a 6 node cluster, right? Let's say data centers, right? So 3 node DC and a 3 node DC, right? We'll call this DC1, DC2. Okay. Now, technically, the key space that we're talking about, application key space, it exists on both, right? Because we said the replication factor is 3 times here, for example. In fact, you know what? I'll say this is like 9, and then this is 9, and this is 18 nodes. All right. So when we do a snapshot, right, we're doing a snapshot on all of them. Okay. If I really want to have high availability, either I'll have a different cluster, or on the same cluster, I'll have another key space. I'll call it application B, and this is application A, right? Blue-green. Blue-green means that one is active while the other is not, okay? And this is also replicated 3 times. And your software, again, you can do it with one cluster, or you can do it with two clusters. You just have to you have to be basically writing data to both places. Your application is going to be writing data to both A and B, okay? And when you're doing this restoration process, you configure the application to only write to, let's say, B, and it's going to be reading from B. During that time, you can do this process, restore A back to what it needs to, and then configure the application to then start using A again. So it may sound complicated, and it is complicated. But you know what? Running a 24-hour application is not easy. Cassandra makes it a little easy because you can have one infrastructure and be doing these things, doing these, restart operations, et cetera, without necessarily bringing down the data. The other approach is what I just mentioned, right? You have 18 node cluster. You have 18 node cluster. You have application A. And we don't really have application B, so it's just application. Okay. And you have a table in here, right? So what happened to the table? Somebody went and deleted some data from here. Okay. Let's say that's what happened. If you take a snapshot and you do an SS table loader back to this, you're going to be able to recover that data while the server is running. But the issue there is that your SS tables may have older data. But there's a way to, I'm looking it up right now. One second. Internet's like so slow today. Oh, come on. bringing up the SS Table loader documentation so we can take a look at it. One second. There we go. So with the SS Table loader, you have a couple of different options. So first is you pick how many connections per second per host. You can connect to all the nodes if you want to. Let's see, you can throttle it. You can say, I want this much, megabits per second. And that gives you a good way to restore that data back. I don't think it has a way to like keep the timestamps. There is a thing called DS bulk, which you can say with DS bulk, preserve timestamps, right? Or to set the timestamp. So in this way, if you were to use DS bulk, if you have a column, okay, with a particular timestamp in that CSV or whatever data you're storing, DS bulk can actually restore the timestamp as well. But I don't think SS Table will be able to do it. But that's a different process. Yeah, it's a good question, really good question. But the only surefire way of like, of doing what you're talking about is kind of having A and B. And I would like to talk through the business use case, right? So what happened? Yeah, go ahead.
Just to add to one more this.
Yep.
Now, I had taken the snapshot, everything. My snapshots are there. I'm doing the upgrade of my cluster. Now, are those where snapshots are still valid, or what happens? Or I need to go for new snapshot?
It depends on which versions. If you change to a major version, then probably not. But they're still valid in the sense that like they'll work, but you're probably better off making another snapshot after the upgrade. If the upgrade is successful, yeah.
Yeah, okay.
Right, but in that case, you're gonna want to keep everything, not just these application key space, right? You want to have the system as well, right?
Yeah. No, if I have to restore I will not be able to take the restore the key, system key spaces, right? Only my objective is to restore the application key spaces. The reason is when I'm upgrading it, my system key spaces, all the structures everything might be changing, right?
Okay, I think I misunderstood your question, but what I understood was when you're doing an upgrade, right? After the upgrade, like if something happens, right, you need to have a snapshot of everything. That's what I was saying. I think I understand your question now in the sense that after an upgrade, do these old snapshots work? Yeah, they can work, but I would say you're better off just, you're trying to kind of have your cake and eat it too, right? You're basically saying, hey, I took a snapshot. It's one version old. I did an upgrade also. Hey, I lost some data. Will this snapshot work? And yeah, technically it will work, but you have to do upgrade SS tables and all that same stuff that you would have to do when you're doing an upgrade to make it work.
Okay.
It
is not just a copy.
You copy it, but you have to run an upgrade SS tables.
Okay.
Yeah. Okay.
Yeah. Okay.
Yeah, let's go back to this outline. So we got here, how does Cassandra store data? Fairly simple. And by the way, there's like a bunch of files, right? These are kind of different type of SS table files. I'll show you what it looks like. So SS tables. Right, so it looks like something like this. right? There's data, there's an index, there's a summary, Bloom filter, compression info, the table of contents or where the stuff is, and there'll be multiple. This is one SS table, by the way. One SS table has basically 8, kind of like 8 files, and then they get compressed and they get compacted, right? So you have a bunch of those files, and you're storing, but that's where everything is there. All the data is there, right? Once you flush it, everything is here for that particular SS table. And a table is a collection of SS tables. When we do a backup, it copies or does a hard link via inodes to this /snapshots directory with a snapshot name if you give it, or it's like a date timestamp, but it has everything, all of those SS tables copied here. So if there's 5 SS tables, there are 40 files in here. How does restoration work? Well, first you have to, there's 2 ways of doing it, right? There's a same topology copy method. In this case, you basically bring down the machine properly, you copy the data back, and then you bring the machine back, 1 node at a time. There's another way of doing it, which is if you have a different topology, but basically you're using a tool called SS Table Loader, also called basically Cassandra Bulk Loader, to take old, well, not old, whatever the SS tables are here, and you're saying rewrite this data back to my cluster. Takes time. This was kind of more.
One more, Maury, with respect to the different topology,
Mhm.
SS Table Loader, in the sense, it's like simulating the DMLs. If I'm assuming, okay, if it is simulating like a DML, that
Mhm.
means what you have mentioned, it will lose the timestamps, right? And if I have multiple SS tables and it was not compacted, compaction has not happened, okay,
Mhm.
then how it will distinguish between, see, for example, I have done one insert, and that is in one SS table. Then I have done an update, okay, that is in another SS table, okay.
Mhm.
Now I have taken the snapshot.
Mhm.
Now I'm doing the SS loader. Sorry, what is that?
SS Table Loader.
SS table loader. Okay. Now timestamp is time, because of the loader, a timestamp will go off, right? Now which data will take?
So, sorry, I have to write it down because
Probably I'm not.
Yeah,
I'm just trying to put it.
Yeah, hold on. So different topology. Start fresh.
A different topology is there.
Yeah.
I have done a insert first. That has gone into the one SS table. Okay.
Okay. Okay.
Then I'm doing a update that has gone to another SS table.
Okay.
Now I have taken the back. I had done the snapshot.
Okay.
Okay. After some time, I'm doing the restoration using the SS table loader.
Okay.
Now, because of a timestamp, we have lost the timestamp. Now, which data will take precedence?
The newest data is always going to take precedence.
How it will know it is a new, which one is a new one?
It won't know. That's what I'm saying. Whatever you wrote last is the latest data. That's how it knows. That's what I'm
That's
trying
what
to
it will take. Okay. Okay.
Yeah, it will take the latest data. As
Okay.
far as I know, I mean, I have not really verified this, but basically SS Table Loader does not store, I'm double checking now. That's what I'm looking at now. Let's see. Hold on 1 second. Okay. Yeah, I'd have to look deeper, but I'm pretty sure it does not store the timestamp information. I'd have to actually look in the code to see what it's doing. Hold but from what I can see from the options, basically, yeah, this is the deal, right? So method uses table loader, right? Make sure the table schema exists. Cassandra can only restore data from a snapshot when the table schema exists. If the table schema does not exist, that has not been backed up, you must recreate the schema. That we're on the same page there, right? You have to have a
Yeah,
schema.
that's what, this is fine.
Okay. Now, if necessary, truncate the table. You may not need to truncate under certain conditions, which I've been talking about. Or if a node lost a disk, you might restart before restoring, so the node continues to receive new writes before starting the restore procedure. Truncating is usually necessary. For example, if there is an accidental deletion of data, the tombstone from that delete has a later timestamp than the data in the snapshot. If you restore without truncating, removing a tombstone, Cassandra continues to shadow the restored data. Okay, so this actually answers it. It does have the timestamp. The SS table loader will keep the timestamp of the older data, but whatever the later timestamp is, delete or update is going to take precedence.
Okay. Now, anyway, moment we have that timestamp, the latest one will always take the precedence, right?
Yeah, but what I'm saying is what this explains to me, okay, is that it's basically saying anytime truncate the table, right?
Yeah.
But at least even in the SS table loader, it will keep the timestamp.
Okay.
Okay.
Yeah.
Learn something new every day. Awesome. Well, no, great. Good question, right? So kind of wrapping this up, almost at the top of the hour, right? At the end of the day, there's two main methods of native restoration. Okay. This whole process, right? So copy method, right? Or use SS table loader, right? Two methods. This is the native manual process. But what you really want to do is use a tool. So Op Center, if you have data stacks, Medusa, table snap, table restore. So if you're interested in any of these tools, go look for Cassandra Toolkit. Yay, we're #1. So Cassandra Toolkit actually explains table snap, table restore, Cassandra Medusa. Cassandra Medusa is has a GUI and everything. So, oh, sorry, I'm thinking of Reaper. Medusa does not have a GUI yet, but basically what it allows you to do, I'm trying to find the website. Oh, here we go. That's what I was looking for. You can do a single node backup, single node restore, cluster wide in place, right? That's the copy locally. Cluster wide remote restore, which is centrally. Backup purge. You can use local storage, Google, S3, yada, yada, yada. Can do other providers. Single tokens or vnodes, full or incremental. So if you're using something like this, right, your job is a little bit easier, but you have to learn a new tool. Okay. And that is time. All right, folks, thanks for joining. Sorry, we started off a little bit late. Hopefully this was useful. Next week, we'll be back, and maybe next week we'll cover data modeling. All right. Same time, same place. Don't forget to subscribe to the mailing list on Cassandra.Link or the YouTube channel. We'll see you guys next week. Thanks, everybody. Bye.
Thank you.